Relative motion. Today's goal is to calculate the times and distances of two objects that are moving relative to each other. The big idea here is that our equation for velocity only has one v in it. And so we're going to have to combine the two individual velocities into one relative velocity by either adding or subtracting, and then use that in our equation. Now, a typical example of relative motion is a jousting match. And so here we have in example number 1, our class mascots Ig and Og jousting from a distance of 100 meters. Ig is going south at 10 meters per second. Ig is this guy here with the spiky hair. Og, he's bald. He's going north at 14 meters per second. How long will it take them to collide? The key here to these problems is to do something that's kind of unusual, and that is to put the origin actually painted on the side of the horse. Anything that's moving towards the back end of the horse, or in that direction, is going to be positive. Anything moving in the head direction is going to be negative. So, Og, he's sitting here on the top of the horse, right above the origin, during the entire time. He does not move at all relative to the origin. So his velocity is 0. Ig, over here with the spiky hair, he is moving 14 meters per second relative to the ground, but since he is moving towards this other horse that's moving in the opposite direction, he's going to be moving a lot faster relative to this origin because the origin is rushing towards him. And so we end up adding the two velocities together. Add the 10 plus the 14, and we get a relative speed of 24 meters per second for Ig's horse. Ig starts off 100 meters away from this origin. We want to know at what time, t, that's what we're looking for. We're looking for the t for that distance to get down to 0. From 100 down to 0. So the delta x is going to be 100. And it's going to be a positive 100 because Ig over here is going to the right, and the right is positive. The equation that we use for this is going to be our simple little v equals delta x over t. Put in our numbers, positive 24 for the v, positive 100 meters for the delta x, and you'll get 4.17 seconds. Now remember, to solve this, there's different ways of doing it, but one way is to put the left side over 1, cross multiply, and divide. Example number 2. During their jousting run, Ig and Og miss each other. Og continues north at 14. Ig continues south at 10. How long will it take them to get 50 meters apart? So here's the picture. Their individual velocities relative to the ground are the same. Their directions are the same. And so the relative speed is going to stay the same. It's still going to be 24 meters per second. The key here is that if the objects are moving in opposite directions, it doesn't matter if they're moving towards each other or away from each other. If they are moving in opposite directions, you add their individual speeds to get the relative velocity. I'll say that one more time because it's really important. If objects are moving in opposite directions, you add their velocities. It does not matter if they're moving away from each other or towards each other. If they're moving in opposite directions, you add the individual velocities. Okay, now then, in our coordinate system, going to the right is positive. And Ig here, he's still going to the right, so his relative velocity is still positive. We started off with the horses right next to each other at the origin. We want to know when Ig has moved to the right 50 meters, and so the displacement is going to be a positive 50. We're going to use the same velocity equation as before, put in our numbers, and you'll get a time of 2.08 seconds. Let's go up to example 3. Ig turns around and chases Og at 20 meters per second. How long will it take him to catch Og if they start 50 meters apart? Now in this case, they are moving in the same direction. Og is moving here to the left. Ig is moving to the left. So if they were moving at the exact same speed, they would never close ranks at all. But Ig here is moving at 20 meters per second relative to the ground. Og is moving 14 meters per second relative to the ground. So relative to each other, Ig is slowly gaining at a rate of 6 meters per second. Since Ig is moving to the left in my picture, I'm going to make it a negative 6 relative velocity. Ig starts off 50 meters away. We want him to get him right up to the origin. So the change in distance between the two horses is 50 meters. And Ig is going to the left, and so it's a negative 50 displacement. Put these numbers into our equation. And we get 8.33 meters. I'm sorry, seconds. Think about your learning. How would you write a procedure for solving these motion problems? What kind of steps? Steps 1, 2, steps 1, 2, 3, or step 4? What kind of rules could you write down that would allow you to solve any one of these 3 problems? Go ahead and pause the video, write down your thoughts, and then play the video to see what my thoughts were. Here's my thought. Step 1, find the relative velocity. If the objects are moving in opposite directions, you add. If they're moving in the same direction, you subtract the individual velocities. And then step 2, use this equation. It does not matter if you have something slightly different. You evaluate your own to see if it's saying the same thing.